Okay, so given the choice for aluminum structures, I would not paint them. I realize we don't have that choice in many cases, especially for the all black vessels, but for any aluminum component, it really is better off not painted. Aluminum doesn't need to be coated to be corrosion resistant. It's fairly well corrosion resistant on its own. When we paint it, we can actually make the corrosion scenario worse. Because if we paint it and then breach the paint, as we will do, it's inevitable somewhere on the structure or on the vessel, once water gets beneath that coating, it puts us into the wet, low oxygen, poultice corrosion situation. So when people ask me about painting things, components again, that are aluminum, thinking that they are adding corrosion protection, you really aren't. Aluminum on its own, from what we call simple corrosion, meaning it's not in contact with other metals, is pretty low. You see aircraft that are, silver, they're not painted. Plenty of commercial vessels, workboats, and things of that sort, even some military vessels that are just unpainted aluminum. That is the preferred approach. Again, I recognize you guys can't do that because you need the pigment issue for vessels to be black or a dark color. So, but just understand that it is not a corrosion issue if aluminum is not being painted. All right, so you recognize this. This is that galvanic series again. A good idea to understand this, and Dan, I don't know if you guys ever post something like that, but it may not be a bad idea, just so you can get a feel for how far apart the different metals are on the galvanic series. Remember, the further apart they are, if they're in contact with each other, the more likely they are to cause corrosion. Stainless and aluminum, we live with it because we can't really avoid it, but other combinations we try to avoid. Now, you probably can't see that from where you're sitting, but there's copper and there's aluminum. So, about 25% of that scale away from each other, that is among the worst types of corrosion that we see is aluminum and copper. So you've heard me say this a couple of times, simple versus complex corrosion. Simple corrosion is a single metal that is simply corroding by exposure to the elements. So eventually aluminum will corrode away into dust at some point on its own. If you put it into contact with other metals, that becomes complex corrosion or galvanic corrosion. That accelerates that process. But on its own, it's pretty corrosion resistant. You've seen this photo already. Dissimilar metals don't necessarily need to touch each other to create corrosion. You can have runoff from unfriendly metals or metals that are unfriendly to aluminum causing this. Again, you've seen that. Okay, so this is an example of simple corrosion. This is an aluminum louver. It's not painted. You can see sort of these white aluminum oxide crystals that are forming on it. Again, you build aluminum boats, you see this stuff all the time. That aluminum oxide material is not harmful to anything. I mean, it's a byproduct of aluminum being exposed to oxygen. It is the film that gives aluminum its corrosion resistance, this aluminum oxide. And it is so hard, in fact, that it's used as an abrasive. You can buy sandpaper that is aluminum oxide. So it is quite resistant and durable on its own if it's not in contact with other metals. So a lot of military vessels, the inside of the vessel that is aluminum is not painted, again, because it doesn't need to be, simply adding weight and expense. Now, if we paint an aluminum structure and then add fasteners to the mix, that's when things start to become problematic. And again, I know that's what goes on here every day, that we can't help it. But once we do that, the fastener fractures the paint. No matter how hard we might try to prevent that, as soon as you put a fastener into a painted aluminum structure, you're going to end up with cracking of the paint around that fastener, and that's what gives us the the beginnings or toehold of poultice corrosions. Water penetrates beneath that crack. It's an oxygen-depleted environment underneath that paint, and it ends up with a blister and then paint failure. So materials that are what we call hygroscopic, that hold water, they're sponge-like, and wood or timber is a great example of that. If that's in contact with a painted aluminum structure, that is also problematic because the water can actually penetrate through the paint. If it's a polyurethane paint, those are not designed to be submerged. They're not designed to be wet all the time. So if the deck of the vessel, for instance, is painted with a polyurethane paint, and then somebody sets down a mat or a rug or a piece of carpeting or something like that on that painted surface, and that whatever is placed down on that surface either stays wet or traps water underneath it. So if it's a rubber mat, for instance, and it gets wet and water is beneath that mat and against the polyurethane paint, it will cause or it will enable the water to penetrate through that paint through osmosis. Unless it's a paint that is designed to be submerged, like a bottom paint or an epoxy primer, we can actually get water penetrating through the paint. So we have to be cautious about trapping water against painted aluminum structures. And this can happen in things as small as just a nylon bushing that is placed against an aluminum or a painted aluminum surface. Water working its way beneath that bushing and held up against that paint for any length of time can cause paint failure. So it's not only breaches in the paint that are caused by scratches or drilling or cutting, but it's water that is being held up against those painted surfaces as well that can lead to this corrosion type scenario. And so here's an example of a blister that is created by water that has penetrated beneath the polyurethane paint and caused the aluminum to become reactive. We're getting this poultice corrosion scenario, so creating what's called aluminum hydroxide, which is the wet version of that white powder that you see develop on exposed aluminum surfaces. So really the reason this occurs is because of a lack of oxygen. Once again, aluminum that is exposed to air develops a very corrosion-resistant aluminum oxide coating, and that all works fairly well. It's once we remove the air and continue to expose it to moisture that we get the problem. So again, an area where there's decking material over aluminum, it may be adhered, it may be a matting that has been glued down to the deck, for instance. Once water begins to penetrate beneath that, that aluminum becomes susceptible to poultice corrosion. This can even happen at plumbing fittings. So if you have a rubber hose, for instance, that's pushed up against an aluminum structure, or even laying against an aluminum structure, that once again traps water against the aluminum, then poultice corrosion can be the result. Structures that require cutouts or holes in the aluminum, any place that cutout exposes raw aluminum and paint that is not fully sealed or bedded in some way, the likelihood of water getting beneath or between those two is pretty high, and the result is a blister like that forms adjacent to the hardware. I can tell you that for painted aluminum issues, for failures in the paint, 95% of the ones I see originate at a penetration where there's a fastener or a piece of hardware. In the other 5% of the cases, it's a scratch or a nick that causes the failure. It's very, very rare to have the paint lift or blister for no reason. You know, just because it has lost adhesion between itself and the aluminum is almost always a causative factor, which is, again, a breach or a penetration in that coating. It's no longer contiguous. Now, we can make this worse by having this breach occur and now also add a dissimilar metal. So when we've got, for instance, a piece of stainless hardware that is attached to a painted aluminum structure, the hardware breaches the paint, you end up with poultice corrosion because the water is going under the paint, and it's wet now, and we've got a dissimilar metal there associated with it. So you can have two types of corrosion going on at the same time between stainless steel, aluminum, and a wet scenario. So it's not always just one case of a single type of corrosion that's occurring here. So how do we prevent all of this? Well, we've talked a little bit about it already. We want to keep those breaches to a minimum, and wherever we have a breach in a painted aluminum surface, we want to fully seal it. One of the more challenging issues is, and I mentioned this during one of the Q&A sessions earlier, is the sharp edges on paint. So this window frame, for instance, it's hard to avoid that sharp edge. If those sharp edges can be profiled so they're more rounded rather than square, it allows paint to adhere to those surfaces more effectively. And in this case, we've got a complex corrosion scenario going on as well, because the gasket material actually has carbon in it, the rubber window gasket. And carbon, as I mentioned earlier, on that galvanic series is very harmful to something like aluminum. They're at opposite ends of that galvanic series. So we breach the paint, you've got water accessible to it, you've got a carbon-bearing gasket there, and you end up with pretty significant corrosion going on, and cosmetically unacceptable paint failure as a result. These cutouts like this, drains in window frames, really, really sharp edges, during the manufacturing process, that is cut out with a milling tool or a router, and it leaves, if not a sharp edge, sometimes a burr even, which the paint cannot adhere to. It runs off of, essentially, and you end up with the beginning of corrosion there. And that can start, I've seen cases where this corrosion on this painted surface has started before the product is even put into service, because the paint coating is so thin there that it just needs some exposure to moisture to become an issue. So rounding these edges wherever that's possible before these structures are painted really makes the most sense, if you can do it. The other issue is areas of entrapment. You've heard me say that a few times already. It could be two metals that have come together, a flange installation that is trapping water against a painted surface, or it can even be a non-metallic structure like a plastic or a non-metallic bushing or washer that has a void between it and the painted surface, and water is getting into that void and being trapped there. So be mindful of that. Any place that creates a gap against a painted aluminum surface is the potential for corrosion. Two different pieces of metal that have been attached to each other in a manufacturing process that then get painted. The likelihood of movement between those metals is pretty high, and it only takes a little bit to crack or breach that paint between the two, and then water penetrates into that surface. And in a situation like this, where water is running down this surface and into that sort of gap there and sitting there, any breach in the paint, the water is going to definitely get under that because it has time to do it. So all of this is very fine assembly and manufacturing details that have a consequence when it comes to paint longevity. So avoiding these wherever possible is always the goal. Areas where you've got water running on a regular basis, so like a limber hole or a drain, running out over a painted surface that then interfaces with something else and water can get trapped. Once again, we've got this is a rub rail on that boat, and it is a black rubber that has carbon in it. Water is running out over that and getting trapped in that gap right there, and you can see the paint is beginning to fail on that aluminum structure. So sort of thinking about this, in advance to the extent you can do it, and then during assembly, if you can't, prevention is always our goal. We really don't want to be dealing with any repairs if we can help it, if we can stop it. So I haven't talked a lot about preparation, primarily because the majority of failures of painted aluminum, the instinct of the people encountering the failures is, hey, the surface wasn't prepped properly, it wasn't primed properly, it's a coating issue. And interestingly, in my experience, that's the minority of cases. In most cases, it's because of assembly issues and not because of the coating. You can certainly do the coating wrong. If you fail to prep the surface properly, if it's contaminated with oil or grease or dust, that can create paint adhesion issues. But those have a different set of examples or clues as opposed to assembly issues that create poultice corrosion in aluminum because water has penetrated beneath it. So I'm not minimizing the importance of preparation. It is really important. You don't want to have paint lifting off of painted aluminum surfaces, but that is, with modern etching primers, that's a lot less likely to be the case than issues that are the result of the assembly of those parts. So how do we get painted aluminum structures to last for a long time? Or how do we get the paint to last for a long time? You know, naturally, as I said, aluminum doesn't like to be painted, so we're sort of forcing this situation. And the best way to ensure really long life with painted aluminum structures is to make sure it's completely encapsulated, meaning there's no way for water to penetrate beneath that coating. So any place it's breached, we need to make sure it gets sealed. We want to isolate hardware. That means flanges, fasteners. Anytime another piece of hardware is installed over a painted aluminum surface, we have to give it some type of preparation to preserve the coating and to keep water out. And again, the most common type of failure, or the most common location for failure, is at hardware installations. It's not happening out in the middle of that surface. It's happening where we've actually damaged the paint unknowingly when we install that flange or fastener. Every time we fracture that paint, it's an avenue for water to penetrate between it and the aluminum structure. So fully bedding those, using a non-metallic insert, a nylon bushing, and bedding is a good way to isolate the two and to preserve the integrity of the paint, or if the paint is breached, that we're sealing it with a bedding compound. Areas that move against each other, and last time I was here I saw some examples of this where you have masts and other structures that pivot or tilt for shipping purposes. That's really hard to deal with because we have wear in those cases, and the paint is going to be damaged at those pivot locations. So to the extent it's possible, isolating those from each other with non-metallic bushings is probably the best that can be hoped for. Where there's a fast pin that's being inserted into a hole that's painted aluminum, again, hard to avoid having chafe there and having failure in the paint. You know, there isn't always an answer to every one of these questions, unfortunately, but there is to most of them. And again, that hole drilled in an aluminum structure that's painted then has a metallic pin put into it, that's probably the most challenging scenario because there isn't a good way to isolate those two. But for a pivoting surface, you can use a bushing that will create isolation. Frank?
Yes, can you maybe explain that it's better to have a line of paint than, like, where there's a friction, for instance? You'd rather have a line of paint?
Oh, yes, okay. So last time I was here, we talked about this, and Frank is reminding me that in some cases, where you do have friction that is unavoidable, like a cleat, for instance. This is a perfect example. You're going to have lines on that cleat all the time. If you paint it, the lines are going to wear the paint off no matter what you do. So in that case, what you're better off doing is creating a nice sharp paint line around that cleat. So the cleat's not painted, the deck around it is, and you have a tape line that you've created. Those tape lines actually surprisingly hold up quite well because they have a pretty thick barrier all the way around the edge. It's not a scratch that's ragged, but it's an intentional border of paint. So for structures that are known to get chafe, and it's unavoidable, again, like a cleat or a hawse pipe or a deck chalk or something like that, where you're going to have a line moving through it and chafing that paint away. You're better off just not painting those components if you're allowed to do that, and have them just live sort of naturally unpainted aluminum, and then everything around it is painted. Is there a question?
In that example right there, you could have the paint line like a half an inch away from that.
You could, yes, you could. That's a perfect example. So you could do away with the paint beneath that, have a nice sharp edge. Cleats are the most common area where you see this. In that application, what I would do, I like the bushing in there. I would bed it as well, because water, interestingly, is going beneath the bushing and exposing itself to the paint. So if you can keep the water out completely, that's going to hold up fairly well. And you can do that with a combination of a bushing and bedding. But a cleat, you don't have that choice. So yes. On aluminum, this is actually on a windlass that's made out of painted aluminum. It's actually powder-coated aluminum. So this fastener has breached that powder coating, and that is going to turn into an ugly mess in a fairly short period of time. Now, in this case, the wrong size fastener was used, and so the head of that fastener is being pulled down into the hole, and it's turning the washer sort of into a tulip. So that's an assembly, a material selection issue and an assembly issue. If that was a flat washer, that would be less likely to do that, but eventually it would damage the paint and create paint failure there. One of the sort of protocols with fastener selection is the fastener should always fully fill the hole through which it passes. So if you've got a flange of some sort, you should be using a fastener that is as large as will fit in that hole, for two reasons. Is you don't want this issue to occur, but also the manufacturer of that flange selected that hole because that's the size fastener they want you to use to install it. So to use a smaller fastener means that it could be potentially under-secured. So always use the largest fastener that will fit in any hole from an assembly perspective. So I think I said 95%, here it says 90, but the solution, the prevention, in the vast majority of these painted aluminum failure cases is really thorough bedding. And when I say thorough, excuse me, I mean you need to get 100% squeeze out all the way around that flange. You need to have excess sealant. It seems wasteful, but it is the only way to know that we haven't left a void in any way around that flange. So don't be stingy with the sealant. Use lots of it, crank it down, get it to squeeze out completely around that flange, wipe it clean. Now you know you've got a good bead all the way around, or a fillet all the way around that flange, and water can't penetrate beneath it. Obviously the fasteners also need to be bedded individually. So that step that's being installed on that painted aluminum mast, lots and lots of bedding material there to get full squeeze out. And as the fasteners are being put in, the fasteners should be bedded as well. And if there's a water leakage issue, if it's going into a cabin structure or below the water line, we need to seal those threads as well. But from a paint perspective, we want 100% contact between the bedding material and the flange. All right. One of the other areas that can be problematic from a bedding perspective is the fasteners, the stainless steel fasteners. All of these fasteners are obviously made by machining processes. They're rolled threads in most cases. They're cut, they're polished. They're contaminated with oil in almost every case. And you can test this by, on a clean white rag, if you wet it with a solvent and then wipe a stainless steel fastener, in almost every case it's going to come off gray like that is. If we're looking for a really good seal between a fastener and the bedding material, especially if it's something below the waterline, we should be de-waxing or degreasing those fasteners with a solvent like mineral spirits before we're actually bedding. Because otherwise we're essentially creating a release agent or allowing a release agent to stay on the fastener that's going to prevent the bedding material from adhering to it. So they really should be clean as you can reasonably get them, especially where water penetration is a concern. If we've got abrasion against a painted aluminum surface, we talked a little bit about this earlier. There are a couple of ways to deal with that. We can use a bushing, non-metallic bushing, or we can just decide to not paint that part of the aluminum so that we're not dealing with the resultant paint failure. That's pretty much impossible to prevent. Again, every fastener that goes into every painted aluminum structure, no matter how small it is, needs to be bedded in some way, because we are going to damage the paint with the fastener, and the only way to prevent paint failure is to seal that breach. So there's various ways you can do this. Again, I've mentioned polyurethane, polysulfide, silicone. We've talked about the materials that you folks are using for this. As long as the material is rated by the manufacturer for the application, I'm okay with it. The most common ones are polyurethane and polysulfide. If the bead is going to be exposed to the elements, it needs to be UV stable, obviously. But otherwise, our goal is really just to seal breaches in the painted structure. What we're doing with this seal is excluding moisture and air so that we can't allow this corrosion process to begin with water penetrating beneath the paint. Okay, that's it. Thank you. Questions? Yeah, good question. So if you're bedding plastic, it does need to be fully bedded because there's still that water entrapment issue. The plastic's not as likely to breach the paint, but if it's a polyurethane paint and you trap water in there, the water can actually go through the paint. If it's there for long enough, it will go through it. So yes, I would say that is still required. And be careful with your bedding selection, because some bedding materials are not compatible with some plastics. So usually the manufacturer of that part will say use polyurethane or don't use polysulfide or something like that. Just be sure it's compatible. Yep. Other questions? Carbon fiber. Question about carbon fiber. Okay, so carbon, again, on the galvanic series, way far away from pretty much everything else. It's a really wonderful material, but if you put it in contact with almost any other metal, it's going to cause that metal to corrode, especially aluminum. Now, carbon fiber structures are technically encapsulated in resin, but if you put it into direct contact with aluminum, it only takes a tiny bit of chafe to then expose that carbon fiber to the aluminum. So we have to treat it like it is making direct contact between the two. So full isolation is the order of the day with carbon fiber. So if it's a carbon fiber component, you're going to fasten it to an aluminum structure. My recommendation would be to have a non-metallic shim in there, a gasket, type material. It could be nylon, plastic of some sort, and bed it so that you can't have any water entrapment there. If you isolate them, it's not a problem. Modern sailing vessels, carbon fiber spars with lots of aluminum hardware attached to them. That isolation approach works pretty well and should be fine. Yeah, good question though. Carbon fiber, great material that we're using more and more of, but it is vicious when it comes into contact with aluminum. The aluminum's going to suffer. Yeah. So, other questions?
Sorry, yeah. So for isolation purposes, what about butyl tape?
Yeah, okay, so the question is for isolation, can you use butyl tape and sealing purposes? I like butyl tape because it's easy to apply. There's no real cleanup issue, or it cleans up very easily. You can pick it up with another piece of tape. The challenge is you need to size the butyl tape so that you get 100% quote-unquote squeeze out. It's not viscous, it's not liquid anymore, but you still need a full no voids between the flange and the surface. And in a issue or a scenario, let's say where cosmetics are more important, the butyl tape leaves an edge that is sticky that becomes dirty. So if it's a light colored boat, like white or gray, and you end up with this dirt line around the hardware, it could be ugly. It's still working great. If it's a black boat, who cares? So I don't have anything against it. Still needs to be used on fastener heads because it's got to seal any damage to the paint, but I like it. I have no problem with it. It's been used for a long time. It's gaining more popularity for flanged installations in marine applications. So, yep. Other questions? All right.
Just a quick one, if you can maybe briefly explain when we paint aluminum, as we discussed last time, how important the primer is versus the actual paint.
Yep. Yeah, so when it comes to painting aluminum, again, an etching primer, because aluminum, I keep saying this, doesn't like to be painted. It doesn't get along with paint very well because it oxidizes so rapidly, and any exposure to air creates that oxidation, which is incompatible with paint. So, so the importance of prepping the surface, making sure it's clean, free of oil, free of grease, free of dust, and then using a good etching primer. Once you've done that, now you've got a surface that is friendly to paint. The etching primer will accept paint very well. So be mindful of that. And the contamination, I have seen cases where I've had paint failure in areas where people were repeatedly touching before it got painted. The oil on your hands is enough to potentially contaminate a surface that's going to be painted. Etching primers deal with that fairly well, but if there's enough of it, sweat, you know, same thing. And any of those foreign materials that are on aluminum before it gets painted can potentially create a paint failure scenario. So you need to treat it like once it's ready to be painted, it's sort of sterile and shouldn't be touched if you can help it, or dripped on with sweat or anything else that's foreign to it.
Your view on aluminum and teak.
Yeah. Okay, so teak is a hygroscopic material. It holds water like any timber does. I can't begin to tell you how many aluminum, very expensive aluminum failures I have seen and been involved with repairing for aluminum vessels that have teak decks. I hate it because water is pretty much guaranteed to penetrate beneath that teak, because nothing really sticks to it for very long. Teak is a very oily wood, so getting bedding material to stick to it long term is very challenging. And any material is going to trap water if it is over aluminum and water penetrates beneath it. Now you've got a water trap. So I discourage the use of teak and other wood in contact with aluminum surfaces, painted or not. Because it is a water trap, and again, something like wood in particular will actually hold water. It'll absorb it and keep that wet surface against the aluminum. So again, I discourage it. I would rather not use that. And some people say, well, how about synthetic teak? You know, that doesn't hold water. And yes, that's true, but I have seen cases where even rubberized non-skid material that is applied over a painted aluminum deck, water penetrates beneath that and gets trapped there. If that's unavoidable, if you have to use some material on the deck, if you're not doing a non-skid surface, or that's the specification from the customer, making sure that material is really well adhered to the deck is going to be critical. That's a surface preparation issue. If you're trying to get something to stick to a painted surface, prepping that paint really well, free of grease, free of wax, free of oil, all of that will minimize the likelihood of water penetrating beneath it. That's somewhat acceptable. Again, if it can't be avoided, if you've got to use it. But wood, I would avoid that being in contact with painted aluminum or any aluminum under any circumstances.
I'm just showing here, I'll just say.
Okay.
So I've got a few reports open from some of the recent warranty claims. 3 of them were from Wayfinder, and Renaissance fasteners are all contributing to the paint failures here on this boat. And same with so this boat, I don't know when Wayfinder left, I think a year ago. 3 boats went out, and all 3 are seeing major paint failures with dissimilar metals here. So, I mean, I can go through these pictures if you want to comment on some of them.
Yeah, that's. I would like to do that. And you know, while I mentioned the scenario of 2 different types of corrosion going on at the same time, the dissimilar metal thing, a lot of people who are dealing with these failures fixate on, oh, it's the stainless steel that's causing the corrosion. Well, if it's a painted surface, it's really, the stainless steel is secondary in concern. It is the fastener that's breaching the paint that is causing the poultice corrosion that then really creates the issue for us. We're worried about the paint failure more than anything else. Don't get fixated on, oh, it's a stainless steel to aluminum issue. As I said, that's important. Those metals technically are not compatible with each other on the galvanic series. But if that wasn't painted, you wouldn't even be thinking about this. You know, it would just be sort of normal corrosion between the two that takes a long time to occur. And this is more a case of the coating being breached by the fastener. So in these examples, that one on the left, you know, clearly that fastener wasn't bedded. It cut into that paint the day it was installed, and that process started, you know, that moment and just got worse. With all those fasteners around that, I don't know how well you can see this, but that paint is all blistered, and it's because of those fasteners. There's no doubt in my mind.
There's also a sharp edge right here.
Yeah, and a sharp edge right there, right? Yeah.
Is that powder coated or painted?
Paint? No, we don't know.
Alex Seal.
Oh, it is paint. Okay. Okay. Yeah, I mean, it's the good news is nearly all of this is avoidable. You know, I've been dealing with this almost my whole career, and I can say that these scenarios can almost all be prevented with not a lot of effort.
Yeah, it's hard to see these pictures.
Yep. Yep.
If I may also add something, if I may, on the white boats. If we look at the production of boats that we make for military and commercial application, most of our boats, if you take D&D for instance, they do an extremely well job at maintaining the boats. And on a white boat, the customers have high demands and high expectations, but they actually quite often don't take care of their boats in terms of prevention and maintenance, as well as military and commercial customers.
Right. Okay, and I would say that there's maintenance, you know, and I tell my clients this all the time. If you have a painted aluminum boat or any painted aluminum structures on a boat, that's almost every boat today, catching this stuff early is critical. So the moment you see paint failure beginning to occur, typically around a fastener or a flange, you know, attack it at that moment, clean it, prime it, touch it up before it begins to spread. And in cases like the photo you had up in a minute ago of yeah, no, go back. Oh, yes, that. You know, these are challenged to begin with because you've got, you know, hard fasteners up against a painted surface. There's not much that you can do to prevent paint failures there, and it looks like somebody put sealant around that socket there.
That comes back to
Design, right. So those are hard to prevent, but in cases where you've done everything you can, and then you begin to have paint failure for some other reason, again, catch it early, and it's a touch-up paint with a little artist brush. Wait 6 months, and it's a, you know, it's a blister that's 6 inches in diameter. So that is part of your owner's manual sort of literature, is to tell people periodically inspect for damage to the paint and where it's occurred to touch it up. That will minimize failures of this sort. So go ahead, Dan, go forward, because there was another one there that was worth mentioning. Okay, so that on the left, that Samson post, that's a great example of something that just shouldn't be painted. There should be a paint line around the base of that. Actually, it's a separate structure. It looks like it just fits into a socket there.
Yeah, it's probably removable.
Yeah, so you could have either not painted it or had a paint line somewhere down there, and it wouldn't have looked bad, and you just have the line, directly against a unpainted aluminum surface, and that would be the way to deal with that. You're never going to get paint to last on a surface like that. The fast pin, as we've discussed, that's hard to deal with. I think, to the extent that you could not have paint on that, I think I would have just not painted that flange there. I left a nice, tape line there, and now you're not going to have an issue with paint being damaged there. You're always going to have water getting trapped in there, and there's a bushing in there, I'm presuming, a plastic bushing it looks like maybe, or it looks like there's something in there.
No bushing.
No bushing, yeah. So, painted aluminum against painted aluminum and movement, the paint's going to get damaged. And so again, I think I would just eliminate paint in those areas and have a nice, neat paint line that'll hold up much better.
Let me see what else is on.
Yep. So again, a piece of hardware that is attached to a painted aluminum surface, those fasteners are cranked down good and tight as they need to be, and the minute you do that, you're fracturing paint, especially around where those fasteners are compressing that stainless steel base against the painted surface. You're putting a crack in that paint, a breach, and water penetrating beneath that, and causing that type of failure. Much of this, preventing this, just comes down to being sort of detail oriented. You've got to look at every place something is touching painted aluminum and saying, how am I dealing with this? How am I preventing damage from occurring to the paint? And that can be done, and it's not a significant amount of effort. Question? So if I heard that correctly, you're saying you're sandblasting or bead blasting the fasteners so that when you paint them, the paint is adhering to them. That's good. I have no problem with that. Yes, I see what you're saying. So when you crank down the fastener, so if you bed it, that's your best hope of it minimizing paint failure. You may not eliminate it completely, but if you're painting the fastener and you're painting the substrate and you bed it, it's going to technically fill the cracks that occur wherever the two are making contact. Again, mostly, if you can. Question back there? No. Okay.
I got another one here. Same.
Yeah. So that's a case of a recess. That's sort of adding insult to injury. It's a horizontal surface. There's fasteners going into it. Water is getting trapped in those, or let's say standing in those. When it gets wet, if it's salt water, it's evaporating. It's leaving salt behind. It's a really challenging situation, and one that's not easy to deal with. And I will admit, you're always going to have water getting trapped in those. Bedding the head of that fastener completely is probably your best hope to extend the life of that coating. And I see you've got the diamond pattern deck material there. That actually looks like it's holding up quite well, but it's easy for that if you have an adhesion failure with that and water gets under it on an aluminum deck. It's really a nightmare. So making sure that that material is really well adhered, that the surface is really well prepped, there's no contamination, there's no fingerprints, there's no oil. Does that mean I'm done? Surface prep is really critical for that. That's an adhesion between a deck material and paint. It's not an aluminum issue. That becomes a painted surface issue.
Yeah, we do a lot of countersunk fast.
Yeah, again, hard to avoid. If it's on a vertical or slanted surface, it's less of an issue because it's not trapping water. Those are failing almost certainly because the fasteners are not bedded or they don't have a nylon insert.
We're using the nile types on the dash.
Yeah, now you are, yep.
Not deck tread. We have a non-skid that gets a seal put around it.
Yep.
And then the tread master does it. Should the tread master get a seal?
Well, so the question is, should the tread master get a bead around it? If you aren't having failures, don't change anything. You know, if it's working, when I do see failures on Treadmaster, it's because it wasn't glued down well enough or because the surface was contaminated with fingerprints and oil and stuff. If you're not having issues, keep doing it. That's fine. Yep. Again, just classic, you know, paint failure around the fastener, and it just spreads out like a halo from there. 100% avoidable in that case. Just good bedding would have prevented all of that.
I don't know what's going on here.
Yeah, that's not your fault, really. Right? That's the engine manufacturer. So that paint being, you know, damaged at that interface between those two components, and then just poultice corrosion working its way under the paint. I don't know how you would. That's an engine manufacturer issue, really, not you. I'll consult for them later. Sharp edges as well, maybe.
What did we get blamed for on the drives, Dan? Nothing?
Question.
If we started using different torque settings on our tools that just beat the crap out of every time, can we minimize this maybe, or?
So the question is, should you be using a torque wrench on some of the fasteners? I don't think it would make a difference, honestly, because I don't think it's a function of over-torquing a fastener. It takes very little pressure to damage the paint. So I think no matter how you control that torque setting, it's based on the diameter of the fastener. I don't think you could put it in properly and still not damage the paint. It's got to be tight. So no, I don't think that would matter. It's the bedding that's going to solve it.
I just want to add right now that when we're talking about torquing, we're not as concerned about the paint as we are about damaging the fastener itself, like stretching the fastener, or if it's a composite, crushing the composite. So when we're talking about torques, it's not specific to what he's talking about. Okay, so because he says that the torquing isn't specific to the paint, that doesn't mean that we don't worry about the torques of our fasteners.
Right.
That's more of the
Right.
Yeah. I see more damage from people overtorquing stuff than
Torque settings are critical for the security of the component. I don't want to minimize that. If you're installing an engine on a transom and the manufacturer has a torque setting for that fastener, you follow that. I don't think it's going to make any difference, as to the longevity of the paint. There are other ways to deal with that. Yeah, torque is critical.
It's all the same stuff.
Yeah. Okay, more of the same, essentially. Yep. In that case, bedding that interface would have almost certainly either prevented that, or it would have taken much longer. It would have taken years for that to occur if there was full bedding between the head of that fastener and the painted surface. Yep.
I think we're using the L-types on these larger deck fasteners now.
Yeah, good. Another question.
Yeah, I was just going to mention that there's been a lot of talk that we're starting to introduce rigid barriers like ladder pipes and stuff. Are you a fan of that? Is that a better solution than just being liberal with
Yep. So the question is using an insert like the nylon insert under the screw heads. We talked about that last time I was here, and what I said was I like that because it's a cushion between the fastener and the paint, so it reduces the likelihood of damaging the paint. I would, in most applications, I would use it in conjunction with bedding material because you will still do damage to the paint, and if the bedding is there, it's going to seal that damage. So I like those. If it's a comparatively dry area, I hate to say it, there's no place that's dry on these boats really, but if it's not exposed to like a weather deck area, you probably don't need to go to that length. But any place that's going to have salt spray on it, I think I would use both. But I do like the nylon insert. I think that makes a lot of sense. It's a cushion. Yeah. All right. Any other questions? Yes. So if I understood it correctly, the question is in a bonding system, are there scenarios where it would be desirable to isolate the metals rather than bond them? As I said, there are two schools of thought with that, which is to isolate and kind of leave them on their own. If it's a naturally corrosion-resistant material like bronze, some people would argue, well, it doesn't need an anode. It's not going to corrode on its own, and that is true. However, the area where bonding comes into its own really can save your bacon is in a stray current situation. If you've got electricity leaking into bilge water, if the metal is not bonded and it becomes part of that path through which that the electricity is taking, you can end up doing really rapid and severe damage to that metal. If it's bonded, that return path back to the source, back to the battery and the battery charger is usually going to be direct enough that it'll trip a circuit breaker or blow a fuse. So personally, I'm of the mind that I like to bond everything. It also comes in handy for, in the event of a lightning strike, it gives you a better chance of surviving that without as much damage, maybe not no damage. And from an electrocution perspective, if the boat has shore power on it, if a bonded component comes into contact with AC power, 120 volts or 240 volts, if it's bonded, it's going to trip the breaker. If it's not, it could just sit there energized until somebody touches it and completes the path. So I think there's a lot of good reasons to bond, and only maybe one reason not to is that you're isolating it. Maybe it'll be okay on its own. So it's a good question, and a not uncommon one. You know, there's a lot of controversy about bonding or misunderstanding about it. So.